boys and girls, it's Mrs. Hernandez, and we're going to review some geometry. So, as Ms. Colhan introduced to you 2D shapes, this week we're also learning about 2D shapes. 2D means two-dimensional. It means flat, like a piece of paper, or like the shape is totally flat. It does not mean something like this. See my salt shaker? That's 3D because I can hold it in my hand. If you can hold it in your hand like a round like this and not just flat, then this is we call 3D shapes. We're going to learn about those next week. But 2D shapes are what we're focused on. And remember, we talked about there's different attributes or ways of describing 2D shapes. One way is to describe whether they are closed or open. We always want to describe ones that are closed. That means the lines go all the way together. Open shapes have a little space in there. See how my triangle has a little space, my square has a little space, my circle has a little space. Okay, that's not what we want to see in a 2D shape. We want to see closed lines. The next attribute we talked about were sides. We've been talking about this for a while. Probably you heard about this in kindergarten. This shape, the triangle, has 3 sides. If I put a triangle right here, I can touch the 3 sides. Those are the longer pieces right here. Those are called sides. I can look at how many sides there are in other shapes too. Like here is my hexagon. I can count how many sides I have in my hexagon. My triangle has 1, 2, 3 sides. My hexagon has 1, 2, 3, 4, 5, 6 sides. That's why we call it a hexagon. Hex in Greek means 6. Okay, so we talked about sides, we talked about being closed or open, and then the last one we're going to talk about is called vertices. I'm going to scoot these up a little bit so you can see all of them. Vertices are just like the corners. Like I'm on a table right now. I have all my stuff on a table. The table has a corner. That's the part where you bump into it and you're like, ow, that kind of hurts. That's called a vertice. If it's one, we call it a vertex. If there's more than one, we call it a vertice or vertices. So going back to our triangle, the vertices are the corners. That's this part right here. So I'm going to touch and see how many corners or vertices I have in my triangle. 1, 2, 3. How many corners do I have on my circle? I don't feel anything. That feels like a corner. 0, right? So circles are one of those special ones. There's no vertices and there's no sides. If you listen to Ms. Thompson read The Greedy Triangle, she's going to read that to you. You can listen to how that happens. Well, let's get another one. Let's get our square here. Okay, so we've got our square. I've got 1, 2, 3, 4 sides, and vertices or corners. 1, 2, 3, 4. Okay, so a square has 4 sides and 4 vertices. All right, we're gonna do a little game together. Are you ready? All right, boys and girls, we're going to play a game together. It's called Same and Different. Same and Different. And in here I have a Venn diagram. Things that are the same go in the center. Things that are different go on the outside. So I'm going to first compare one of our attributes. We're going to compare sides. So I'm going to put the sides right here so you can see that's what I'm talking about. Okay, and we're going to compare number of sides. Okay, all the shapes that have 3 sides, I'm going to put here. Ones that have more than 3 sides, I'm going to put over there. Okay, and then we're going to try to figure out what is the same. Okay, so let's see. Which of my shapes has 3 sides? The rectangle or the square? You said rectangle, you're right. So here's a rectangle. Found another rectangle has 3 sides. Okay, so this has more than 3 sides because it has 1, 2, 3, 4 sides, doesn't it? What about my rectangle? Let's count the sides. 1, 2, 3, 4. Okay, so that has more than 3 sides. So I'm putting all my 3-sided ones here. Anything with more than 3 sides over there. What about my hexagon? Okay, that's 1, 2, 3, 4, 5, 6. Definitely more than 3 sides. So that goes over here. All right. What about my circle? Can it come into this? Does it have 3 sides? Can I put it here? No, it has no sides. Can I put it on this side? No, because it doesn't even have more than 3 sides. It doesn't have any sides, so I can't put that in my Venn diagram. What is the same about both of these? They may have different numbers of sides, and they even have different numbers of vertices. If I go back and I count the corners, this has 1, 2, 3 corners, and so does that one. This one has 1, 2, 3, 4 corners, and so does that one. This has 1, 2, 3, 4, 5, 6 corners. So they have different sides. These two have different sides and different vertices. Are they closed shapes? Are both of them closed shapes? Yes, they are. So they have different vertices and different sides, but they're both closed shapes. So I could put this here. They're both closed shapes. Now, are they all 2D shapes? Yes, they're all 2D shapes. So if I wanted to make another card here, I could say they're all 2D shapes. They have different sides, they have different vertices, but they are both closed shapes and they're both 2D shapes. Now I want you to go ahead and practice looking for those attributes as you do your independent practice.